Hello Zainab, this is Mr. Caslin. I wanted to go over these problems that you sent me. We've done these types before, so it's just a quick review on how to work these. Let me make sure my recorder is going. Okay, everything's set. Now, this is a division of rational functions. So remember, divisions you want to turn into a multiplication. So turn it into a multiplication and then flip the second fraction. So what's on the bottom is going to go onto the top. And what's on the top is going to go to the bottom. Still writing with a mouse, so still don't do that very clearly. Okay, so division, turn it to a multiplication. Flip it. Now you want to factor and cancel. You have the difference of squares here. You have this difference of cubes here and the sum of cubes here. Remember the formula for factoring the difference of cubes and sum of cubes. Now when you factor these, so this is the sum of cubes. When you factor these, you have a binomial and a trinomial. So sometimes the trinomial factors further. So you want to look at that. Okay, that shouldn't be too difficult. On that one, this is just a straight multiplication, so you want to factor and cancel. Looks like you have a greatest common factor here. You have a greatest common factor here. These are trinomials, so just factor those into two. I'm going to factor those into two binomials. You'll have a 2x and an x. You have to figure out what numbers are going to go here. Well, you're going to get a 1 and a 1, and then plus and plus. So you'll factor those, and then cancel the terms that are alike on the top and the bottom. All right, so down here you've got asymptotes. Okay, so I know you've got that. Some notes written on one of your papers about the rules for asymptotes. Here, the degree of the numerator is greater than the degree of the numerator. Okay, before you do that though, go ahead and you've got some factoring here. Again, you've got a difference of cubes that you can factor, and then you've got a trinomial that you can factor. Now remember, you're going to have a hole if something in the numerator cancels with the factor that you have in the denominator. All right, so say you had an x minus 3 or an x plus 3 in both. Those would cancel, then you would have a hole at negative 3. Okay, vertical asymptotes, the rule is the same for all of these. What makes the denominator 0? Horizontal asymptotes, if the degree of the numerator is less than the degree of the denominator, you've got a horizontal asymptote at 0. If the degree of the numerator is greater than the degree of the denominator, you do not have a horizontal asymptote, but you could have a slant asymptote. If the degree of the numerator is equal to the degree of the denominator, you're going to divide the coefficients. 3 divided by 2. That's your horizontal asymptote. Now this one, you could combine into one fraction, or you could graph just this part and it's going to shift a vertical shift of 7. Okay, so this one, be careful because you've got a degree of the numerator is less than the degree of the denominator, which would make a horizontal asymptote at 0, but then you've got a vertical shift on this one. The whole thing's going to shift up 7, so it's going to shift your horizontal asymptote. Okay, so these are, that's a keep, change, flip, factor and cancel, keep, change, so keep, change, flip, factor and cancel. Here, factor, see if you have any holes. You've got difference, she's really testing you on the difference of cubes here, because there's a difference of cubes here. Factor those. See if there's any factors in common that could create a hole. You've got factoring going on here, so you want to factor all of these problems first, see if anything cancels out and creates a hole, and find your vertical asymptote where the denominator is 0. Horizontal asymptote, you've got the 3 different rules depending on the degree of the numerator and degree of denominator. This one, you have a basic hyperbola, and then it's going to shift, a vertical shift of 7 on that one. Okay. Hope this helps. We will talk to you soon.